Okay, so in this video, we are going to be talking about the functional group Alkoxy, which makes up the organic family of ethers. We're first going to talk about their physical properties. Okay, so as I mentioned, we are going to be talking about the functional group Alkoxy. This is going to make up the ether organic family. And the structure, the primary focus here is that sandwiched oxygen that exists between two R groups. The next slide, I'm going to show you a few examples of what these look like. Okay, so as I mentioned, the primary focus here is going to be that sandwiched oxygen. So with both of these examples, I've got an oxygen between two R groups, and those R groups could be anything containing carbon. And again, that we're focusing on that sandwiched oxygen. All right, so here we're going to be talking about the properties of alkoxys. So as far as their polarity goes, they are polar molecules, and they are going to be polar in their immediate bonded region. So what I mean by this is we are looking right here at this oxygen, and that is where you are going to see your polar bond. So it is going to have some dipole-dipole interactions. Now, as we've talked about, depending on how large those R groups are, that's going to have an impact on whether this is going to behave as a polar or nonpolar molecule. It also has the ability, because it has this oxygen here with the lone pairs, it has the ability to act as a hydrogen bond acceptor. And so this is going to make it, again, depending on what the overall molecule looks like, it is going to be able to interact with water. So because we're talking about solubility, the solubility is going to be low, generally due to those nonpolar groups that are surrounding that oxygen. And when we are looking at the range of solubility, hydrocarbons will be least soluble, followed by halos, then ethers, and then alcohols. As far as our phase change goes, because we've got those dipole-dipole and hydrogen bonding, this is going to play a factor in those phase changes. Still going to fall in that same range between the halos and the ethers.